Okay, the next section is Chapter 10, Topics in Analytic Geometry. And it's not geometry like you remember. So the first thing we're going to do is lines. Today's goals are to find the inclination of a line, to find the angle between two lines, and find the distance between a point and a line. No. Do you have notes? I can move on. All right.
Say hi to Marco.
Hi, Mario.
It's me, Evan.
All right. So the definition of an inclination is if it is a non-horizontal line, it's the angle that it would make with the positive x-axis. So, forgetting all this, going back to trig. Remember in trig when you first started drawing angles, you started with the vertex of the origin. Your initial side was always on the positive x-axis. Do you remember this?
Yeah.
And then you had your terminal side, and then to measure that angle, you started from the x-axis and you went in a counterclockwise position. You said that this was theta.
Yeah.
The only thing we're doing today is we're doing basically the same thing except for we're making it a line. So if I have a horizontal line, then my slope is going to be 0, right? My slope is 0. My angle would be 0. That is theta. If I had a vertical line, vertical line. If I'm going from here to here, what is that angle going to be? 90 degrees. So theta would be 90 degrees. But what's my slope on the vertical line? Undefined. Remember, I have a rise but I have no run. Okay, this one, if I have, here's my positive x-axis, I rotate. What type of angle is this? This is acute. So my theta is, well, I'm not going to say theta, but I'm going to say it's an acute angle. And then, what's my slope? What type of number is my slope? Positive. And the last one I have this line here. I go to measure the angle from the positive x-axis. That's going to be an obtuse angle. And then what kind of slope do I have? Negative. So, you remember from trig. I hope you remember from trig.
I don't know much from trig.
If I go here, go 1, 2, 3, 1, 2, 3, 4. If I had this line that went through the point 3, 4, and I asked you to find this angle, you would, back in trig, you would make a triangle, yes?
Yeah.
Here's your theta. This is 3, this is 4. What is the slope of this line? What's my rise? 4/3. My slope is 4/3. To find this angle, I have the opposite, adjacent. What trig function is my opposite over adjacent? Tangent. And that's how we get this formula that my slope is going to equal the tangent of the angle. Is that double? So this one, if I have this angle here, where I have this line here, and I know that this angle is pi over 4, then if I want to know what the slope is, how would I find the slope? I would say the tangent of pi over 4 would equal my theta. No, I'm sorry, would equal my slope. And what's the tangent of pi over 4?
Oh, Lord.
Oh, Mrs. Passick is so sad right now.
Square root 2 over 2.
The sign is
No,
square root 2
it's
over 2.
one.
It's 1.
Oh,
Yeah.
I don't
Yes,
remember
I'm
this.
so glad he said that. Did you hear that? Unit circle. It's a thing. It's a thing that you learned, not memorized. You learned,
I know
which
that.
means what? Where'd you do it again? You still have to know it. Yes.
Oh, I memorized it. Yeah, I memorized it. I don't remember.
So let's start with two problems. So the first one, I had the square root of 3x minus 3y plus 3 is equal to 0, and I'm asking you to find the inclination of the line. So the first thing I have to do is find the
Yeah.
I don't have finding
Slow.
slope, so I'm gonna put this in y-intercept form so I know my slope. So I'm gonna rewrite it as the square root of 3x plus 3, I'm putting 3y on the other side. Divide everything by 3. So we have the square root of 3 over 3x plus 1 is equal to y. I only needed this, that's all I really needed. So my slope is the square root of 3 over 3.
Is that X outside of the, was that outside of the square root the whole time?
Yes. So now I'm writing it, I'm going to say the tangent of theta is equal to the square root of 3 over 3. You're looking for an angle, going back to your trig days, if you're looking for an angle, what do you have to use? Inverse. You have to do the inverse tangent. So this is on my unit circle, right? I know this from my unit circle.
Where does negative or square root of 3 over 3?
It's not. But the tangent is. There is a place on your unit circle where the tangent is equal to the square root of 3 over 3. There's 2 places. But the inverse tangent, you should remember, is only defined in 2 quadrants. First and fourth. Very good. First and fourth. So my answer, when I do this either mentally or on my calculator, if I have it written this way where it's an inverse, I should only give an answer from the first and the fourth quadrant. Since this is positive, I'm going to answer from the first quadrant. So when is the tangent equal to the square root of 3 over 3? You know what? Oh, no, I'm right.
Pi over 3 or pi over, I don't know.
It's either pi over 3 or pi over 6. 50-50 shot.
I think I'm 50-50.
Pi over 6 is
Pi
the
over
last. Is that the answer?
That's the answer.
Let's go.
Pi over 6, that's in radians. What's it in degrees?
30.
30. Because the sine would be 1/2 over the square root of 3 over 3 at pi over 6. These are square root of 3 over 2. These would simplify. You'd be left with 1 over the square root of 3. When you rationalize, that's how you get that. But let's face it, if you didn't know it, what would you do?
Put it in your calculator.
Put it in your calculator.
Okay, so like, what's the answer that we should?
Put it in my pocket.
You're gonna do, it depends on the question. Sometimes it asks for in radians, sometimes it asks for in degrees. Yes.
At pi over 6, wouldn't the y point be square root of 3 over 2?
No. Pi over 6 are further to the left than you are to the x side.
Yeah. Yeah.
All right, try the next one. This one is not on your unit circle, so you're going to have to use your calculator to find the inverse tangent.
You said we have to use our calculator for this?
You're going to have to, yes. Yes, I agree. So your slope is 5, so 5 is going to equal the tangent of theta. So you're going to do the inverse tangent. Chris, can you do me a favor and tell me what you got for radians first?
1.3734.
734, and then when you change that to degrees, it was 70.
78.6901.
How do you do 180 over pi?
You can multiply this by 180 over pi, or does anyone know a quicker way? Oh, did you guys ever learn the DD button?
No.
Oh, I love the DD button. So when you hit menu on your calculator, no, not menu, you hit that book, the catalog thing. So if I'm here, if I have this, go up and grab that again. And then you hit the catalog and you go down to the D's and you're looking for 2 capital D's. DD. Not menu, catalog.
It's the book next to
I feel like we did learn that. I don't know if I can jump midstream into this. DMS.
We did work.
So what was it, 1 point what?
1.3734.
1 point. Then you hit the book, CD. Good?
That seems a lot harder than doing it.
No.
Okay, I added another one. I don't think this is on your note sheet, but you're gonna squeeze it in there somewhere.
Too bad, so I don't know.
Okay, beautiful.
203 was in.
So this one, when I find the slope, I'm gonna have, divide by -3, -3. So my slope is -2/3. So then I'm going to say tangent of theta is equal to -2/3. So on the calculator, I'm going to do the inverse tangent. Now we talked about this before. This is going to give me an answer from what quadrant since it's negative? Fourth. That's going to be a slight problem. Because my angle, my definition of an inclination of a line is it has to be a positive angle. It's going to give me a negative angle. So I'm going to have to somehow adjust that. If someone give me the angle first, both in radians and degrees.
Radius is -0.588.
588 and then degrees.
Negative 33.69.
Or 3.what?
69.
So on my, this is where it's giving me the angle. It's giving me this angle down here. I actually want this angle up here. What can I do to make it in the second quadrant when it's in the fourth quadrant? Add 180 if I'm in degrees. So this one I'm going to add 180 degrees. And what am I going to add here to the radians? Pi. So if I have a negative slope, I'm going to have to add pi or add 180 degrees to adjust it so that my angle is an obtuse angle. I don't know, and I'm afraid to do mental math today.
So you have to do what, add 180?
Add 180 to the degrees, add pi to the radians.
What? The one in degrees is 146.31 degrees, and the radians is 2.554.
Okay? So when you're doing the inclination of a line, it has to be an angle between 0 and 180 degrees. Well, 0 and 179. Okay, the angle between two lines. So now I'm going to try and find, if I have this angle, and let's say this angle was 40 degrees. I'm just making these numbers up. Let's say I say this angle was, I don't know, let's say 20 degrees. Then this angle here, oh, that's bad enough. Let's say 10 degrees. And this angle here would be 30 degrees. And you're going to subtract them.
Yeah.
And this formula here, which, I didn't do a special gift. You should look familiar to you because last year you did these, right? It is the same thing as difference of tangents.
I'm going back to Detroit. Yeah, why are we going back to Detroit?
Why not?
Hey, I'm giving you a special little gift. You know what's special about this little gift? It's a little. It has every formula for chapter 10 on it. It is something that you will be able to use for every test or quiz that measures chapter 10. So when we take the exam in a couple of weeks, and there's some sections from chapter 10, you'll be able to use this piece of paper. You are not allowed to put any additional formulas on here or example problems, else I will throw it away. You will not have it. It's that. Okay, you ready to do one? Okay, I have line 1 and line 2, and I want to find the I want to find the angle between those two lines. So what I'm going to have to do is I'm going to have to find the slope of both sets of lines and then put them into that formula. We good? Okay. So here, line 1, I'm doing in red. 2x minus 4. Oh, I should not have done it that way. I did. It's okay. So my slope for line 1 is -2. Does everyone agree? Doing line 2 with blue. My slope for line 2 is going to be 1. Putting into this big formula, that's the value. Slope 2, which is -2. Oh no, slope 1 is 1. 1 minus -2 over 1 plus -2 times 1. It's 3, right?
Yeah.
-1?
Yes.
So it would be -3, but I'm just going to make it 3 because I'm taking the absolute value. Now, how do I find the angle?
Arctan 3.
Arctan. I'll use a different one. Where would you get?
1.24 and 3.
Or 1.2?
1.25. And then in degree we do 71.57.
Everyone good? Did we get that? That's all you have to do. That's not bad. Hard way, harder way, is you would find the angle of one of them, you'd find the angle of the other two, and then you subtract the two angles. This one's just sort of condensing it all into one. Oh gosh, no. Because now we have to do the distance between a point and a line, so we can find the area of any triangle. So this is a formula that you're taking a point that's not on the line, and you find the distance from that point to any line. In order to do that, the line must be written in standard form, so it has to be set equal to 0. That's the part everyone forgets. And then your coefficient of x is a, the coefficient of b is y. No, I said that wrong. The coefficient of x is a, the coefficient of y is b. And you just plug into that formula. So you ready to do one?
Yeah.
Let's do one. So I want to find the distance between the point 0, 2 and the line 4x plus 3y is equal to 0. So just to be clear, my a is 4, my b is 3, my c in this case is 0, my x sub 1 is 0, my y sub 1 is 2. So I'm going to do the distance, so it's going to be a positive number, that's why the absolute value sign is there. I'm going to take 4 times the x coordinate, plus the coefficient of at y times the y coordinate, plus c, which is my constant, and divided by the square root of 4 squared plus 3 squared. The numerator is 6. The denominator is square root of 25. So then it's going to be 6/5. So 6/5 of a unit is how far that point is from that line. I feel like we must do another.
Yeah.
I feel like I'm going to let you think for a second and try that one on your own. I'm going to pause the video. So, all right, so this one, when you had to rewrite it as -7x plus 3y minus 11 is equal to 0. So now when I find the distance, I'm going to take 7, or negative 7, times 3, plus 3 times negative 2, plus negative 11, all over the square root of negative 7 squared plus 3 squared.
But the actual value is on the other top half.
You know why the absolute value is only on the top half?
No,
You're right, but because you can't have, there's no way that you take the square root with a negative number.
gotcha.
So, okay, never knows this one on the top half. So this is negative 21, negative 6, negative 11,
Negative 38.
so negative 38. That's an 8. And then this is 49 plus 9. So this will be 38 over the square root of 58.
Yeah.
There's no perfect squares in 58, is there?
No.
So, here's I get torn. I would like you to rationalize, but the next set of problems will tell you not to rationalize, so I'm like torn.
So smart.
I like to rationalize, it makes me happy. Did everyone rationalize? Or just, simplify. Okay, the reason why we find the distance between a point and a line is so that we can find an area of a triangle that doesn't have a, I can find the altitude. Does that make sense? Because when I didn't think I mentioned this, but when I'm finding this distance, when I find the points and the distance between the line, it's always going to make it so that it's perpendicular to that line. That's the distance that you're finding. So when I go to find the area of a triangle, that distance between that point and this line is going to be the height of that triangle. So, find an area formula for area of triangle, 1/2 the base times the height. So the height is going to use that distance formula we just learned, right? This is going to use the distance between 2 points. Are you with me? And then 1/2 is 1/2. I'll say it again really slow. 1/2 is 1/2.
All right.
This V is the base, so I'm going to find the distance between point A and point C. Remember the distance is like the difference of the x squared plus the difference of the y squared?
Yeah.
You take the square root of all that?
Is X2 minus
So what, distance formula?
Yeah,
plus Y
distance
minus-
formula, yes. And then this one is going to be the formula that we just learned. The distance between the point and the line. So it says find the altitude, so I want to find this first. This is what I'm going to find first. I'll do all this work from blue.
Our numbers are different than the last one.
Oh, you know what? Which numbers do you have?
3-1.
Do we have to find
For
the?
C, so
Wait.
everything.
No, everything's the same just for you.
C is 3-1,
Yeah.
and then this makes all these numbers in the triangle form.
Yeah.
Do you have to find the distance between, like, the distance of the base first?
I'm going to find it second. It doesn't matter. It doesn't matter what order you do it in.
Yeah, but we don't have the point for the middle one, so we have to do midpoint.
No, we don't know that point. We're going to do this. When I find the distance between this point here and this line here, it's automatically going to make it a right angle.
So
Yes.
you don't have to find a point, it's just the line.
It's just the distance. We're just going to find the distance. We're not going to find the line.
Okay.
We're just going to find the distance from here to here using the formula I just learned. Okay? So the first thing I have to do, I don't know if this is the question you have, is I have to write the equation of this line here.
Yeah.
So to write that equation of that line here, I'm first going to have to find the slope. So I'm looking from A to C. What is the slope from A to C?
Oh, we have to minus y.
Yep.
All right.
So that's going to be 1 minus 0 over 3 minus 0, and I get a slope of 1/3. Then I'm going to write the equation. I'm a point slope person. Why is that like the y minus y sub 1 is equal to m times x minus x sub 1? So my slope is 1/3. I'm probably going to pick the point A because that by far is a much easier point, right?
Yeah.
So I'm going to have x minus 0, and then this will be y minus 0.
Ms. Ford, why do you need the line?
because the formula that we just learned, I have to write the equation line as ax plus by plus c. So right now, I'm going to have y is equal to 1/3 x. I don't like the fraction, because I don't want to put that fraction into my formula. So what can I do to get rid of that fraction? Multiply everything by 3. When I do that, I get 3y is equal to x. Then to write in standard form, I'm going to go x minus 3y plus 0 is equal to 0.
Do we have to plus 0?
No. Now, using that formula that I just learned, I'm finding the distance between this line and the point B, which is 1,5. So I'm going to do distance is equal to my A, which is 1, times 1, plus -3 times 5, 0. All of the square roots of 1 squared plus -3 squared. Everyone with me?
Is the bottom? Okay, absolutely.
It's not, I always wrote it as, but it's not, and it's never going to be negative. Why is it never going to be negative? You can't get a negative square root. So, I mean, if you put the absolute values over the whole thing, you're not changing the equation at all. This is -15, so I'm just going to write 15. And then the denominator is square root of 10.
14.
What? Oh, 14.
Nice.
Bad math.
Bad math.
Bad math. I'm going to leave the square root of 10 as the square root of 10 for right now. Okay?
Echelon?
I said I'm going to leave the square. I'm going to leave it like that. I'm just going to leave it like that. So if I'm thinking here, area of my triangle, 1/2. I don't know the base yet, but I know my height is 14 over the square root of 10. Everyone with me? Yeah. I'm a little sarcastic.
For sure.
Now I need to find the base. So the base will be the distance between these 2 points. So the distance between 3, 1 and 0, 0. So I'm going to use the distance formula for that, for AC. That's the square root of what? X2 minus
X1
squared.
Y 200.
Squared. So putting in what I know. I will not skip steps. I want to skip steps. I will not skip steps.
Yes.
Are we good with trying to skip to square root of 10?
Yeah.
I thought you said I wouldn't skip any steps.
You flip-flopped, right?
I flip-flopped them.
The X or the Y. It
Oh, I
doesn't
did.
matter.
I did. You're right, I did.
I understand how we do it.
So here, my base is square root of 10. Yeah. The square root of 10 will simplify. So my area ends up being 7 square units. I will guarantee you that as long as you do not simplify or do something funky, your radical usually simplifies out. Let's go. Yes.
So when you're making the original line, you chose like.
Yes. So you will still end up with the same line. All right, moving on. There's this one. This is an extra one that I really want you to do. And so I'm going to pause the video so Mario doesn't have to listen to this, but does he have to do this one? Mario! All right, so what you should have done is you should, so if I find the slope of this, so I'm using AC, so the slope is going to be -2 minus 0 over 5 minus 4. Why do I feel like that's not right? That is not right. Difference of the y's. -2 minus 4, so much better. 5 minus 0, and I get -6 over 5. Then I'm gonna choose this point to put in point slope, so y minus 4 is equal to my slope, -6/5 times x minus 0. When I do this, I'm gonna have y minus 4 is equal to -6/5 x. Bringing the 6/5 over, can I multiply 5 at the same time? Yeah. Because I want to get rid of that fraction, so we multiply everything by 5. So I'm gonna have 6x plus 5y minus 20 is equal to 0. Distance between the point and that line. 6 times the point is 4, 5.
I think my one collapsed.
5 times 5 minus 20. All of the square root of 6 squared plus 5 squared.
Yeah.
So the numerator ends up being 24, 25 minus 29.
Yeah.
And then the square root of 61.
He's kidding.
Then finding AC. This is between AC, that's the square root. I'm doing x is nothing, so -5 minus 0 squared plus -2 minus 4 squared. Oh, yes.
Why'd you find the slope or the equation of A to B?
I found the distance from AC to B.
Yeah, but on the slope thing, you did the slope of A and
No, I did -2.
oh wait, never mind.
So this ends up being the square root of 61 as well.
I'll be the first to find out.
So the area of the triangle, 1/2 the base square root of 61 times the height, which is 29 over the square root of
Good basketball
61.
game.
These simplify, and I'm left with 29 over 2, or 14.5. Square units, good?
Work, bud.
Woo! Just to refresh, this is due on
We got a picture of this?
Friday.
Friday.
This is due on Tuesday.
Oh, my.
You-
This Lord, that's like,
A lot of work.
that's a lot of work, this Lord.
Yeah, you know what, here's the thing, and I'm gonna say this to Mario too. The test on Thursday, Friday, bring your book because you will finish that test early, and that way you can start your homework. If you don't bring your book, I'm just gonna go on to 10 too. Deal?
Are we gonna have a video to watch for Monday or Tuesday?
You know, I thought that might be a little,
I agree.
Me talking.
You're good, I mean,
oh my.
You're gonna